Hey there, Year 12s. Without a word of a lie, this is my second attempt at this video, so I'm kind of lost the first half of it, but I'm going to try my best to try to redo it so that way it all works out. Here we go. So, we're going to get going today on annuities. An annuity, the good news is about having to redo it is the focus on this video is way better, so the image clarity is going to be way better. An annuity is a form of investment that involves regular contributions to money. Ooh, that's a cue. Regular contributions of money. For example, superannuation, also known as, or aka, super, is an example of this. I'm investing in my super. I think I'm investing about $200 per paycheck into my super, as an example of that. So dependent on, I'm sure, payment scale or pre-agreed ratios, but different people are investing at different amounts into their super. Apparently that's a big thing in the news right now, is that people are withdrawing their super out to kind of to supplement income or to kind of make up for a loss of income as well. I've heard a lot about that in the news with kind of what's going on right now. An annuity is different from a compound interest investment because there is an additional regular payment being made. It's not just a one-time investment of money and the money just sits there. So let's look at an example. So if I have $1,000 that I'm going to invest yearly, at 10% interest at the end of each year. So, number one, we're going to let V be value, and it'll represent the value. So, the value at the end of year one. Value at the end of year one. So, we're investing at the end of the year. So, at the start of the year, at V0, our value is going to be 1 plus, how do we use that interest rate? We change it into a decimal to be 0.10. And then we are investing, at the end of each year, we're investing $1,000. So we're adding $1,000 each year. Okay, so if I do that math, I had $0 at the start of the year invested, so we can't earn interest on $0 really. So the end of the year, our value is $1,000. So the next year, year 2, or the value at the end of year 2, it's the value of year 1 plus our interest rate plus another $1,000. We're invested $1,000 each year. So last year our value was $1,000 plus our interest rate, and then multiplied by our interest rate, and then with an additional $1,000. So if I do that math, I get says $2,100. So now year 3. Year 3, we take our value from year 2. We're going to multiply it by our interest rate. And at the end of the year, we're also going to add another $1,000. So we take the value from year 2, which is $2,100, you're going to add, multiply by our interest rate, and then add our $1,000, and that's going to get us to $3,310. Year 4. So we'll do this over 4 years. We take our value from year 3, multiply by our interest rate, which would look like $3,310 multiplied by our interest rate with our new $1,000, and I believe that comes out to $4,641 is our final value after 4 years of investing $1,000, then $1,000, then $1,000, then $1,000. To do this, there's actually a really easy way to do that on your calculator that I'll be showing you later on in the video. That kind of cuts through having to do this again and again and again and again and again, and it kind of just helps you whip through that really quick. To help you out, we are going to be using something called the sorry, just give me a second here. I'm just flipping through my old notes. The recurrence relation. So the recurrence relation has some different pieces of information. So there's something called the recurring. This is the formula we'll be using. It's the recurrence relation. For an annuity. There's 2 different formulas, and they're not that crazy from each other. There's an investment situation, and if you're investing money, or if it's a loan and you're paying off the loan. So those are the 2 different types of annuities. There's an investment annuity and a loan annuity. With an investment, it's VN plus 1 equals 1 plus R. Add your deposit because you're contributing to your investment. And a loan, it's VN plus 1, it's 1 plus R, and you're subtracting the deposit. You're paying down the loan. So that's the big difference, is whether you're adding or subtracting. VN plus 1, explain your terms. So VN plus 1 is the value of investment after a certain number n plus 1 payments. So after 2 payments, after 3 payments, that's what this is. Vn is the value of investment or loan after n, like 3 or 4, 2 monthly payments, 3 monthly payments. R is your rate of interest. You make sure that it's as a decimal always. Decimal, and then finally D is the payment, and the D comes from deposit. Per compounding period. Now, I lost the first half of the video, made it right to here. This is what I lost. So I'm going to write recall, do 2 dots, I'm going to pause right there, and then it might jump as I splice the 2 videos together, but this is where I'm going to stop and then splice the 2 videos together. Alright, so see you in the other video. I'm not even going to give you I'm going to adjust the focus, and then I'm going to get going. Oh, beautiful. Blinded by the light. That's so much better. So recall. If the interest rate is 10% per year / annum, then, and is compounded monthly, then we take the interest rate, which is 10%, I change it to a decimal, I divide it, R equals, I take the interest rate and change it to a decimal, I divide it by the number of months in a year, which is 12, and then I get, I'm just getting my calculator in on this, divided by 12 equals, and then I would get 0.008 3 continued, and that would be my interest rate that I would use in the question. So let's look at a question, and I'll show you how to do this with the calculator using a different shortcut method. So I'm doing example 1. So Alyssa borrows. So I'm just going to kind of do the Alyssa borrows. Alyssa borrows $1,000 at a rate of 15% per year or annum, compounding monthly. She will repay the loan by making 4 monthly payments, each monthly payments of $257.85. So with questions like these, it's important to think about what is important. So number 1 item that's important is the $1,000. That's going to be the total amount that she owes. Number 2, we have an interest rate of 15% per year, compounding monthly. That's important too. She will repay the loan by making 4 installments of this amount. So that's our deposit. So what we're going to do is we're going to start out, because this is a payment, it's a loan, it's not an investment, this isn't a loan, we're going to use the formula of Vn plus 1 equals Vn 1 plus R minus D, because it is a loan. That's why we're going to use minus, because it's a loan. You make that a minus. So the next thing we do is let's figure out R. So what does R equal? So R equals our interest rate of 15% divided by the number of months in a year, which is 12, to get an interest rate of 0.0125 per month. That's helpful. D is our deposit amount. She'll be paying $257.85. So we now know R, we now know D, and we're ready to get going with this. Now, we can do this in 4 calculations like I did earlier in the video. That is possible. However, we can do this a little bit easier with your calculator. So I'm going to try my best to explain this, and I'll also model it using the calculator. So, you know the amount she owes, the total amount she owes is $1,000. So we're going to figure out the VN. So VN is the $1,000 that she owes. That's the money that she owes. Is everybody good so far? So to start, we're going to repeat this 4 times, this calculation. To save you time, what you're able to do is you can do this with the first payment, the second payment, the third payment, and the 4th payment. So the first payment's going to be $1,000 times our interest rate of 1 plus 0.0125 minus her payment, which is $257.85. That's what it's going to be. And then the next time we do it, it's going to be whatever the answer of this is. So this is going to be our answer. That answer goes in here, and we'll multiply by the interest rate, which is 1.0125. I don't need to kind of write this out. And then it's going to be her payment. And that's going to equal this amount right here. That's going to come right here for my third amount. I'm going to multiply by that by our interest rate. Subtract our usual payment. That's going to make our new value. We're going to take that value again, bring it down to here, multiply it by 1.0125 minus 257.85. And I can hear Rowan already like thinking in his head, he's like, oh gosh, this would be so much math. So there's a calculator way to do this. And I'm going to bring my calculator in. Sorry if the screen's hard to see. Let's see if I can turn the light on again. See if we can get the light to turn on. I don't know if that helps at all. Okay. So on your calculator, what you're going to do is I'm going to type in 1,000, which is our initial amount. You type 1,000, and then you press the equal sign. After you press the equal sign, you'll notice it shows up down here in the answer area. Next we go multiply by, so it goes to answer, so you'll multiply by our interest rate of 0.0125, so that's this right here. And now you go minus our payment amount, so 257.85. And so what that does is now this is going to repeat this part of our question each time with our answer. So if I press equals the first time, it gives me our first value of 754.65, which I give myself a bit more room. So 754.65. That comes down here, 754.65. I press equals again, it does the math for me again to get 506 point, I'll just round that to 23. That comes over here, 506.23. I press the equal sign again. After the third round, it's 254.71. That also comes over here to 254.71. And then I press equals, and it's 0.04 is the last amount. So that's after the 4 years, all the math done out. So with your calculator, you can do that, and it's really, really easy, straightforward thing to kind of set up. So we've now filled that out. Let's go through this. So we've created our recurrence relation. That's A. So that was A was creating the recurrence relationship. That was A. B was using our calculator to solve that. Was the balance of a loan she still owes after she's made 2 payments. After she's made 2 payments, the balance at the end of the second month would be here. She's made 2 payments, and this is her balance after 2 payments. Is the loan fully paid out after 4 payments have been made? Is the loan fully paid out? No, she's still 4 cents short. So she would have to pay the 4 cents and probably include interest on that as well. But that would be how to do that example. There is a second example that the textbook gives you, and it has a table. So it has Spencer making an initial deposit of $1,000 over 1 year and at a rate of 7.2 per year. So this question has a table for us. So it's n plus 1 has Vn. It has the deposit amount that Spencer's making, and it has our Vn plus 1. Sorry if this is a little bit of marathon, but I'm just making sure it kind of is making sense. So what we're going to need to do is, for example 2, it has Spencer. This is example 2. And for example 2, all my computers went to sleep, hope it didn't die. Well, I think we're good. I'm just going to just tending to my computer here for a second. So it says that Spencer makes, I'll just take a second and I'll write it out. So Spencer makes an initial deposit of $1,000 on an investment taken out over a year at 7.2% per year, per annum, and compounded quarterly. That's important. And compounded quarterly. Compounded quarterly, and additional, so he's investing on top of it, $100 is made each quarter. Deposit each quarter. Sorry if that's getting a little bit blurry. Let me just move this. Is deposit each quarter. Complete the table for the first 4 deposits. So complete the table. And that's that table right here. Complete the table for the first 4 deposits and calculate how much interest. And calculate how much interest has been earned. Alright, so what I'm going to do is I'm going to flip back and forth. But there's the table that we're going to complete. There's the question that's being asked. Important things to note. So there's an initial deposit. There's no E on deposit. What am I thinking? There's an initial deposit of $1,000. The interest rate is 7.2% per annum, and it compounds quarterly. That's important to know. An initial $100 is deposit, so that's our annuity right there. Is deposited each quarter. Complete the table. So what I'm going to do is I'm just going to flip this over and I'm going to flip back to complete this. But that's kind of the question that we've been given. So here we go. So the first thing I'm going to do is I'm going to write a recurrence relation. So our recurrence relation for this one is Vn plus 1 equals Vn bracket 1 plus R, and this time am I subtracting or adding? I'm adding my deposit because it is an investment. So it's plus D. So the first thing we need to do is our D is $100. Our rate is going to be our 7.2%, so that's 0.072 divided, so quarterly is divided by 4. That's going to equal 0.018, so that's our R value. So we have D, we have R. What is our initial value of everything? So what's our Vn? In this case, it's going to be our 0, so V0. Our value at 0 time is going to be $1,000, because remember, he made that initial deposit of $1,000. What a smart guy. So we're ready to go. For V1, so our first quarter is going to be V0, 1 plus R plus D. So let's fill in our information. V1 equals V0, which is $1,000. 1 plus R would be 1.018 plus the deposit of $100. Now we are going to repeat that, so whatever that equals will be what our V1 equals. Quarter 2 will be that amount we just found times the interest rate plus another $100. That answer will be our V3, which is this amount right here, times our interest rate plus $100, and I believe we have to do this for 4 years. So that's V4 equals whatever our investment rate is, 1.018 there's our song telling us that classes are rotating. So what I do in my calculator now, this is how we're going to do this on our calculator. So to start out is we start with our $1,000. So I do $1,000. You can't see. So I do the $1,000. My computer's just glitching there. There we go. So I take the $1,000 here and I press equals. So it shows up here. I now do multiplied by my interest rate 1.018, and then I also type plus 100 equals. So there's our value of our investment after the first year, $1,118. I now take that value and it actually goes right here. I press equals again to get 1,238.12. Press, oh, I write that right here. I now press equals again to get 1,360.41. I rewrite that down here. And I press equals one more time, 1,484.897, so I'm going to round that to 1,484.90. So what we're able to do now is I can now take this information and use it to fill out the table. So I'm just going to flip back and forth here between my work and the table. So my deposit each time is $100. So that should be easy. 100. For my first quarter, second quarter, third quarter, and fourth quarter, we now have that done. So our VN is going to be this value, then this value, then this value, then this value. So it'll be 1,000 the first time, then 1,118 the second quarter, 1,238.12 the third quarter, and 1,360.41 in the fourth quarter. The VN plus 1 is our final value, right? I'm just waiting for my camera to catch up. It's going to be here, these values. So it's the value at the end. So on the first, it's going to be 1,118, 1,238.12, 1,360.41, and then finally it's going to be 1,484.90. So there's our table completed. So we need to figure out how much interest was earned. So let's think about this for a second. You know at the start, so how much interest? So interest earned. How much interest did he earn? Well, we know in our head that he initially invested the $1,000. He then did the 1, 2, 3, 4 payments of $100. So that would be $400. So you know that the total amount of money he invested is $1,400. And that's our principal. So that's the principal that he has invested in. So we're able to now do this as the total amount that it's earned, so 1,484.90 minus the 1,400 that he earned. So that's the total value minus the amount of money that he actually invested. So that's the 1,000 initial plus the 4 payments of $100. And if I quickly do that, I believe it's $84.90 is the interest earned. I hope that helps you out with your practice. I'm sorry about it being a 32-minute marathon of talking, but I knew it was going to be a little bit of a hard one, and I thought I would do it with paper. So I'm glad I got it, figured out how to focus the camera, so I feel a bit blurry at the start. Take care.